already completed on our SLS lesson. If you have not yet completed it, then you really need to go and catch up. Okay, so on our SLS lesson, right? Okay, we covered several objectives. The very first one is that we must know how to convert percentage, fraction, and decimal. Okay, conversion of percentage, fraction, and decimal. Just correct this. Okay, which is in fact a skill that we have already learned, okay, when we were in primary school. Right? I would expect that you know how to convert percentage, fraction, and decimal itself. Okay, so just a very quick example, because I did look through the work. Okay, some of you don't quite know how to actually write your answers yet. So for example, when we are given 91.4%, okay, for presentation wise, okay, percentage actually refers to over 100. We get 91.4 over 100. However, I want to emphasize that this is not a fraction. Okay, why it is not a fraction is because a fraction is being defined that the numerator and the denominator must be an integer. Okay, 91.4 is not an integer. Okay, fraction must be numerator and denominator. Both must be integers. That is what a fraction means. Because I saw some of your inputs when it comes to conversion to fraction, you write it as a decimal over 100. This is not a fraction. Okay, so to convert it into a proper fraction, you can use your calculator to help you. 91.4 over 100, and then you see that your calculator will give you 457 over 500. Okay, and this is then a fraction, right? Then again, use your calculator to help you to convert 457 over 500 into a decimal. Okay, and you will get 0.914. Right? So I want you to try using your calculator, making sure that you know how to use your calculator. Okay, and you can get 457 over 500 and 0.914. Okay? Okay? Then, that is for percentage conversion into fraction and decimal. If I have a fraction itself and I want to convert it into a percentage, okay, I will put 4 over 7 times 100%. Okay? Make sure that you, when you're writing, we put in this percentage sign. Okay? Because otherwise it is not equal. If you don't have the percentage sign, we cannot say that 4 over 7 is equals to 4 over 7 times 100. Okay? Because this is just 4 over 7 one. This one will times 100. Having the percentage sign makes this entire thing to be equal to 1. Why is it so? Because 100% refers to 100 over 100, which is equals to 1. So 4 over 7 times 1 is equals to 4 over 7. You understand? Okay, so presentation-wise, make sure must be times 100%. Cannot just times 100. But when we press our calculator, we roll times 100. Okay? You never ever have to press the percentage sign in your calculator. Okay? Up to this stage when I'm an adult, I still never press percentage sign in my calculator. Okay? So I don't even know why is it shown in the calculator at all. Alright? So in this case, 4 over 7 times 100 in your calculator, you will then be getting 57 and 1 over 7 with the percentage sign following along. Okay? Likewise, even when we are converting a decimal itself, okay, we also multiply by 100%, but when we press calculator, we press times 100, and you will get 54.32%. Okay, you can write a percentage either in a decimal form, or you can write it as a fractional form or mixed number form. Okay, either one is acceptable. Okay. Another example. If I have 49 and 1/3 and I want to convert it into percentage, likewise, okay, I will times 100%, and using my calculator, I will be getting 4933 and 1/3%. Okay, try to give your answer to exact where possible. That means in a mixed number form or fraction form, okay, rather than in decimal. Okay, usually I don't write recurring decimals as well because sometimes your dot for the recurring can be difficult to spot. Okay, and then we did one last one. Since we did a mixed number over here, let's do another small maybe okay, if I have 2.0016 and I want to convert it into a percentage, so 2.0016 times 100%, okay, and we will get 200.16%. Okay. So your percentages can definitely be more than 100. Alright? Need not always be stopping at 100 itself. Okay? So that's our very first skill that we covered in our SLS. Okay? Converting percentages to fraction and decimal. Next thing, which is about finding percentage of a quantity. Okay, so when it comes to finding percentage of a quantity, or in fact any word problem itself, please make sure that we know how to present our answers. So the emphasis that I want to put over here for me to go through a question is really about how to present our answer. So I'm going to make use of exercise 8A, question 7. That's in your textbook, page 13. So let's take a look at this question. Multi-story car park. Given that 30% of them are blue, we want to find the number of cars which are not blue. Okay? So first of all, how many percent of the cars are not blue? 70, right? Because we know that in total it's 100% minus away the 30% which is blue. So the percentage of cars that are not blue is actually 70. So we will write that percentage of cars that are not blue to be equals to 100 minus away 30, so 70%. Okay, so this will be how we present our answer. Please don't give me loose working, okay, which doesn't quite make much sense. Okay, sorry, maybe I should put in a percentage signs here. Finding the number are not blue, that will be equals to 70%, alright, of your 120 cars, and we say off, we actually reply, meaning to say multiplication, so times 120, we can write 70% as 70 over 100, and then multiply by 120 to get into 4. Okay? Right, so please make sure that you present properly. Don't just give me very independent calculations. Okay? Then I want to run through practice now for because it was one of the questions that you had to answer on SLS itself. Okay, so looking at this question, it says that Wei Ming was asked to find the value of 3.6% of 1000 kg. And his answer was 3,600 kg. Without performing any calculations, explain to Wei Ming why his answer is incorrect. So the keyword over here is without performing any calculation. Okay? In the question that was posted on SLS, I did give you some structure in terms of how to answer the question. I put in the structure that says, since 1% of 1000 kg is something, then something. Okay, kind of like asking you to fill in the blanks. Okay, I hope that those that did it, you do find this familiar. Okay, then after that it says, therefore 3.6% of 1000 kg something, so 3,600 kg is incorrect. Okay, so most of you are able to tell me that 1% of 1000 kg is, oh sorry, not 100 kg, 1000 kg is actually equals to 10 kg, right? Okay, so is 10 kg. Okay, because 1000 kg itself, if I divide by 100, okay, to find 1%, I will find that it is 10 kg. So that's just a very simple calculation, right? Okay, then this blank over here, there's a little bit of variation in what some of you actually try to explain. Okay, some of you say that things like maybe 100% is 1000 kg and this is 10 kg. So 3.6% cannot be more than 1000 kg, right? Because if 1% is 10 kg, this is just 3.6%, okay? And this is 100%. So it can never be more than 1000 kg, okay, to hit 3600 kg at all. Okay, so some of you explain the direction, right? One way that you could actually choose to explain, okay, also is that then 4%, okay, because we know 1% is this amount, we can see just 4% how much is that going to be? 1000 kg. Okay, I'm not trying to say that this is the only way of answering it correctly. Okay, those trying to argue in a manner that 100% is 1000 already, 3.6 cannot possibly be more than 1000. That is actually a correct answer. Okay, just an alternative here is that we can see 4% of 1000 kg will be 40 kg. Okay, this is 3.6%, slightly less than 4%, cannot be more than 40 kg. Okay, so therefore 3.6% of 1000 kg should not exceed 40 kg. So 3600 kg is actually incorrect. Okay. Alright, questions? Okay, so in your test or exam itself, okay, please don't just only know how to calculate, but then you need to know how to explain also. Okay, so you will be asked things like that to actually explain the situation. So that's why, okay, in your SLS we always have those kind of questions for you to explain. Okay. Objective, okay, was in expressing one quantity as a percentage of another quantity. Okay, so one such example. Okay, that I want use to actually emphasize a certain thing is exercise 8A question 11. Okay, so will you please turn to your, you don't have to read that. Okay, so never mind. I'll just write it in short, okay, because the question quite fairly long. Okay, so in exercise 8A question 11, they made use of a little bit of chemistry, okay, where they said that sucrose is a compound produced naturally in plants from which table sugar is being refined. It has this certain formula. I'm not sure whether you have touched upon the chemistry aspect in your science already or not. Okay, but this is a chemical compound formula. Okay, which means that it is made up of 12 carbon atoms. Okay, and then each 22 actually refers to 22 hydrogen atoms. And then O11 means that there are 11 oxygen atoms. Have you covered the periodic table in your science already? Yes? Okay. So I hope that you can recognize C stands for carbon, H stands for hydrogen, O is oxygen. Okay? And then they create a certain compound. Right? Not trying to teach you chemistry over here, but in this particular question, okay, it was asking us to find the percentage of hydrogen atoms in the compound. Okay, so to find the percentage of hydrogen atoms in the compound refers to everything over here. Hydrogen will just be this, which means that there are 22 hydrogen atoms. So to find the percentage to present our answer, you can write down required percentage. Okay, so that you don't need to write such a long sentence sometimes. Okay, required percentage in this question refers to the percentage of hydrogen atoms in the compound, and that is found by taking 22 hydrogen atoms out of everything added up together. Okay, the total number of atoms in the compound, followed by multiplying 100%. Okay? And then you can key the entire thing to your calculator without the percentage sign. percent.